this little mini lecture has to do with the properties of infinite limits. As you can see, I've got just a few little properties here. A commonality among these things like limits, infinite limits, derivatives, integrals, you're going to see a lot of this sum and difference, product, and quotient. This down here should have been labeled quotient. Okay, so we're trying to get, the object of this is if you have this set up, or you can get this set up where you have the limit of some function within this larger function tends to infinity, and the other function tends to something other than infinity, then we can work these into our advantage. Okay, so if one is infinity and the other one is not, then the sum and difference go to infinity. The product go to infinity or negative infinity, depending on whether or not the limit of the other one is positive or negative. And then the limit as if f tends to infinity, and you have f of x over g of x, and the limit as x tends to c of f of x is infinity, then the limit as x tends to c of f of x over g of x is infinity as well. However, if you flip that so that you have the limit now as x tends to c of g of x over f of x, then that's really 1 over infinity, which is just 0. Okay, and so if the bottom goes to infinity but the top doesn't, then the limit is 0. All right, so let's take a look at an example here. Let's go ahead and let's take a look at number 33. And 33 simply says this. We are looking at the limit as x tends to 2 from the positive, or from the right, and we're looking at x minus 3 over x minus 2. All right, so now, if we just direct substitute 2 in, we notice that the top is negative, and we notice that the bottom is positive because x is bigger than 2. It's tending from the larger side of 2, and so this bottom is going to be positive. This will be negative. This will be positive. And so overall, our value is going to be negative. All right, and so, but the bottom is going to go to 0, which means this thing's going to explode. It's going to be an undefined, so you're going to have kind of a 1 over 0 look. But since it's negative, it's going to explode into the negative regions, and so the limit as x approaches 2 from the right is going to be a negative infinity. Your bottom is growing, or the function will be growing without bound. Okay, and this is making use of this of the quotient rule. Okay, so let's try to find one that makes use of something different. Let's say something like number 47. 47 says let's take, oh, that's another quotient rule. Let's take a look at number 45. So we have the limit as x tends to pi, and we're looking at the root of x over the cosecant of x. Okay, now be very careful here, because I don't recall too much about the cosecant other than it's 1 over sine. And so I can rewrite this as the limit as x tends to pi. This becomes the square root of x over 1 over sine of x. Okay, so as pi tends to, or as x tends to pi, sine tends to 0. So we can, again, we can look at this another way. We can flip it. So we can take the limit as x tends to pi. And now if I put this into fraction form, I really have this. So I have to invert and multiply. When I do that, then that gives me my sign. So this will come to limit as x tends to pi of the sine of x times the square root of x. But the limit as x tends to pi, if we substitute that right in, sine of pi is 0, and the root of pi is some real number other than 0. And so 0 times anything is just 0. So this is going to go, as we approach pi, this thing is going to go to 0. This thing is going to go to the square root of pi. 0 times the square root of pi is 0. And so that's how we can figure out something like number 45. For an example of an addition or subtraction, let's take a look at number 41. We are going to take the limit as x approaches 0 from the left of 1 plus 1 over x. So that means that this is the limit as x approaches 0 from the left of 1 plus the limit as x approaches 0 from the left of 1 over x. Okay, so we're approaching it from the negative side, so x is going to be negative. This thing, as you move smaller and smaller and smaller, this number is going to get bigger and bigger and bigger. And so this is going to shoot off towards negative infinity. This is just going to be 1. So the limit of 1 as x approaches 0 is just simply 1. The limit of 1 over x as x approaches 0, however, is negative infinity as you're approaching it from the negative side. And so 1 plus negative infinity, that just simply means negative infinity. And that's how they get that.